Okay, so just to recap, we have basically a mod file, a mod.rs, that refers to a machine that's going to give us a behavior of this kind under. Features are the suite of tests we are going to write. We are going to have all the suite of tests here, and we package that in a module called as a lib. And in order to use any of this guys outside the lib, we have to make this as pub. So now we don't want this features to be available the outside world. So what we can do is we can just make this pub mod mission, because mission is something that should be exposed to outside world. For example, from main I have to access the mission. Okay, so now what we are having, now it is saying that this exchange for is never used, but we are using that in features. As we are using that as part of the test, it is saying that we are not using that in the main. So if you put this as pub mod lib, still it is now that error gone. So this is what's a pub modding a particular lib. So if you put this mod lib, we are getting a complaint that you are having this exchange for, but you cannot use it. It's not that all the methods that whatever I have created in a model that I have to use within this main. Probably I have to expose this to the outside world. So how to do that is you just make this lib as a public one, and then rest will understand that, oh, this guy is going to make this particular method as an API, so that people outside of this module can use that. So that is what is a hint you are providing. So it is going to give you every possible advice. You are having something cannot used. So if you are planning to make this to be available for others, then just provide those hints for this. So that is what pub modding a lib. Okay, now if you go to this mission, we know that we cannot use this input. We just return the p.toString irrespective of the input. Please wait. So the features, it is saying that this mission is not at all used, but we know that we are using this mission. So how to do that is, if you go to this mod.rs, just mark this feature as, it is a, configure this as test. That's it. So it is not going to complain anything now. Now we are all ready to start provide our test one after the other. So if we run this cargo test again, so we have one passed and we have only one warning, that is input help. If this is intentional, prefix it with an underscore, but it's not intentional, fine. So we have to start use that. So now our stage is set. Now we have to start provide the requirements one after the other, and we have to make the code to respond to this requirement. So if I provide, so this is a hack that what we did here, right? So if I pass 1, then it has to return p. So if I pass 4 here, then it has to respond with 4p. So let us make this test to fail. Sorry, cargo test, not run. Fail. Cool. Because the left is p, the right is 4 p's. So in the mission, we know what we have to do. Let us create a string. Result. We have to provide a string. So the way that you can create a string is this. Then we are going to have a for loop, simply for I in 0 ... input, similar to Python. So within this for loop, we are going to append as many do we have something called as an append or push? Yeah, we have a push method that can accept a character, so we just use P here. So now it is saying that the result is not mutable. See this? The result cannot borrow result as mutable as it is not declared as mutable. So just note this point, borrow, we'll come to that later. So result as mutable. Now I am going to just make the minimum thing that is required for this mute. Okay, and then what is that I am using now? So I am not all using this I. Okay, or even you can simply leave this to avoid any warnings. So result dot push now will be populated with P 4 times. Now we have to return something. See the error now, because if the last statement is not having a semicolon, it's an indication that it is a return statement. Now let us return that result. So everything is green now. So let me just collapse this. We don't want the tree structure hereafter, and we'll just focus only on these two things. One is mission and our feature. So feature is our guideline, specification, mission is an answer for this. Let us run the cargo test. Passed. So let us split right. Okay. So let us write the next. Test. So what's the next test? So I have to repeat this mission each and everything in each and every line. Let me put that here as exchange for, so that I can avoid this mission every time. Simple change. Cargo test. If I, so let us go to the next requirement. Nickel is 5. What I expect is, if it is 5, then I want n as an output. It's doing its job correctly, but wrongly. PPP 5 times, that is what we wrote. So now what we'll do is, we'll just provide one more hack. If result, if input is what is you can do, if input equals 5, then result dot push n, and then this may get into this particular loop because it is going from 0 dot input. I don't want that to go to this loop, so what I will do is I will just input minus equals 5, so that it won't get into this loop. Oh my god, so now this input is not mutable. So now let us do a simple trick. Now let us let input equals given input. Let me make this input as given input, avoid changing it multiple places. So let's check if so hack works. Suppose if I provide a E6, should be N followed by P. So what's it doing? So it is input equals 5. Now I provided 6. So it won't get into this thing. So I will make this as a while now. Instead of if, let us make this as while input is greater than or equal to 5. So this is going to satisfy this condition 6. So now don't do any refactoring. Let us wait for some more inputs. So we are going to defer our decision of making any further refactoring. So this, so we will go to the next thing. That's what is it? Let us provide a 16, 10, 5, 1. So we are expecting a D for that. What to do? So the first test is if I provide 10 plus 5 plus 1, what I am expecting is D and P. But it is giving you 3N and P. Technically it is correct, but this 2N can be made into a D. And what we can do is we put one more while. If it is greater than or equal to 10, then we put D here, and what is happening is we put a 10 here. So this will go like a cascading while loop. In fact, this is also a while loop. You can think of this as a while loop. Cool. So you are seeing that it is a pattern is emerging out of this. So let us try to make this into a while. While input is greater than or equal to 1. Do you see? Oh my god, I have not implemented this. Reduce this input minus 1. We do not have something called as the input minus in Rust. Okay, so don't try this. It's input minus equals 1. So it's pausing. So now we are seeing a pattern now. While input is greater than or equals 10, then push D. Input greater than or equals 5, then push N. Reduce that much from the input. So how to convert this 3 duplicating kind of code into a elegant and efficient code? So a trick for that is that we can have this input, that is 10 and D somewhere, and we can create a for loop that will go through that particular kind of component that will give each and every time whenever I am asking, give me the next, give me the next, give me the next, kind of an iterator that is going to give this pair of D and 10, and then I can put this particular while loop within that while loop. So it's subordinating this while loop within another while loop or a for loop. Okay, so this is going to take some time, this refactoring. So let us introduce a second thing called as we need a character and a number combination. There are several ways that you can do with a tuple, But let us take one more step ahead. Let us create something called as a struct, because this we are going to use multiple times in our journey. So this struct name requires a name. So let us call this as some unit, or it's a mission. So right, so it is going to have different slots for this to contain the coins. So let us use a word called a slot, and every slot is having a name for it. So what is this? This is a denominator, or the slot name, or the code, or whatever it is. Let us use a word let's provide something as a denominator, or denom, or unit, simply unit of measurement. So this is going to be a character, and then a value, face value of that is going to be a I32. Okay. Do we really need an I32 for that? Let us decide that later. So we are going to have a slot, and the slot is a combination of a unit and a value. A typical slot will be something like this. Let slot equals slot of unit colon ten, and unit colon D, and value colon. So this is a representation of the slot. You can instantiate a slot like this. So you can create slot 1, slot 2, slot 3, lot of things. So another way to do this kind of creating a slot instance is you can create a function to produce it. Is something similar to the builder. You can build a slot using a implementation of slot. Something similar to this string colon from. So we can create one more function, and we can give a name for this new, and we can pass this character and the value. If we pass a character and the value to this, and value is I32, we can make this to return a slot. We call this as an associative function, and this is going to do this. Is going to return let a slot equals slot of unit command value. So if you use the same name or value command, whatever you provide, the rest will take what is it. Based on the name, it will infer that you mean by this value and you mean by this unit. So it is. So Rust takes as much care as possible to automatically map this thing. So now we have to return this slot. So yes, slot. That's it. So this is a way that you can create you can ask the slot itself to give an instance of that. So now what we can do is we can use a slot colon new, and we can pass this D, and now instead of curly braces we can provide it. Cool. So now we don't want this let a slot equals slot unit value, so rather we can remove this, we can remove this, remove the semicolon, simple. So we have a function that is going to build a slot for you if you offer the unit and value. So it's a very simple exercise for you to create an instance of slot. Okay. This kind of a function is a very special kind of a function. We will revisit that again later. And this is how we can have slot. So now what we need is, in fact, we need an array of slot, a slot for D, a slot for N, and a slot for P. So if you, in Java you used to have an array list or a vector, or in Python you can have a array, you can just create something, a sequence for this. So in the same way, we can create an array of slot here. So how to do that is, there is something called as a vector, and what is a vector? Let slots of type vector of slot. So you can, this is how you can create a vector by colon new. The same way that we created a struct with a new, the vec is also having a new. So it's a custom that what we follow in Rust community. To create an instance of something, we use a new. That what we are using in Java and elsewhere. Okay, so what we can do is we can put a new, and then we can add to this, if it permits, or append to this our slot, the D slot. Then appending one more vector, I believe, slots dot push. Yeah. So it's going to comply now with an error because the slots is not a mutable one. Cannot borrow slots as mutable. We saw this already when we created our string. We had to have this string as a mutable. So here this, one way of doing this is make this mutable and push the slots into that. Another way of doing this is, so let us first do that, but then we'll go for a different way. Let us call this a slot D. So followed by slot nickel and a slot penny. This is 5, this is 1, and we are going to put all the slots into this. Seems very verbose, right? So is there a better way to do that? Yeah, we'll do that shortly. So now what we are going to do that is, now we have these slots. A vector of slot, that what we mean by a slots, and each of the slots corresponds to a particular denomination D10, and instead of, so now instead of writing this many while loops, we can simply put one more while loop for slot in slots. So now we got this slot now. So we'll take one while loop and subordinate this while loop within this for loop. So while input is greater than 10, instead of this 10, what we can do is that this 10 will be separated from the slot dot value, and we have a 10 here, and this is also slot dot value, and the push slot dot go. That's it. So now we have a very great algorithm with just two loops, the for loop, a while loop. The for loop go and ask this, if this input is greater than this value. If not, then it will go to the second slot, then it will go to the third slot, kind of. So now we don't want all these while loops. Let us check whether our idea is working. Cool. So what is advantage of this thing. So it is not just, it is becoming a more elegant and efficient code. And let us see how this is extensible now. So if we have to now go to this quarter, that is 25. So let us put this 47 now. So for 47, we are expecting a quarter, that is 25, followed by 2 times 35 and 45, and there will be 2 p's. So QDDPP, QDDPP. There is no nickel because the quarter supplies a 5. So if you put a cargo test, now it should fail. We know that. What it results in is, it is giving 4DDD and a nickel PP. That's technically correct, but the expectation is QDDPP. So if you go to this thing, we'll create one more slot. Let's call that slot as Q, and the face value of that is 25. We will add that slot carefully before the D. So that's the trick of this. We are arranging the slots in the decreasing order of their face value. Parsing. So simple changes that what we are making to make this to parse. Now you know how to extend this for the $half. So if someone is giving us 55, then it should give me a $half and a nickel. So let us put 55 plus, let us put this as 56, then it should be H and P. Let us see the failing test. It's a practice. So it's giving you QQNP. So $half is 50, has a 50 face value. So we need one more slot. Let us call this as H. Give 50 here. Carefully add this before this quarter. Fine. What's happening? Okay, the value is beautiful. Now we have one more requirement, that it has to return an error message when my input is 0. So before we do that requirement, we'll check if there is a way that we can reduce some lines of code here. We are having a vector and then we are creating slots. So there is another easiest way to do that is, now let us try to put these things into a different method so that we can get the slots from there. So that will improve the readability of the code. So we will create one more. So there is no in Eclipse for Java we have a refactoring, and we can just put this thing and we can put that into a method. So we'll do that manually now. So fn get slots. So what's going to do is it's going to return a vec slot, and where to house this particular function. We don't want this to be a public, and we can have this variable within the, but also slot itself to give us the list of slots. this has to return this slots. I'm just going to put a slots here, and then now we can call this slots as let slots equals let slots, and where this slots is, it is inside the struct called a slot. So we are going to call this as slot colon get slots. Simple. So now, because this is just a builder kind of a function that is going to give us a vector of slot. Okay. So we have now this. I hope this improves readability. So we are having an input, and this is the result I have to return. And then I am asking someone to give me the list of all the slots in a hierarchical order, and then we are iterating over the slots, and we are getting a slot, and then I am just comparing the slot value with what is my balance I am having, and if it is greater, then we are putting that much unit, and then we are removing this value from the input, and finally when everything is done, then we are returning a result. Okay, so now the readability is improved. Now we are going to the second or final requirement. This is going to the first requirement. So if I ask for an exchange for of 0, what I am expecting is it has to give me some error message. So this can be handled in a way. Rust gives us an ability, either you can return something as an option, or you can return something as a result, the true result. Wait a minute. What I mean is, the signature is going to be, if I put an exchange for .0 dot is error. In case if it is error, then it has to tell that it is error. Exchange for 0. If the result is of type error, then it should be asserted that yes, it's an error, and otherwise it should go like this. So the way that you can achieve this in Rust is, you can put a result string followed by one more string or something. So result has two things. One is a string, that is what is a normal behavior. So if everything is fine, this is okay. If anything is okay, then this will be returned, and if something is not okay, then this will be considered. So now we have changed the structure of the method to return not a string but a result of string and followed by a string. So just put this as okay of this result, meaning we'll discuss these things again later. So just now have a look at the pattern, that is result string, and if something is not correct, for example, if given input less than or equal to 0 also, we have to return please provide value greater than 0, or the minimum acceptable value is 1. Handling the edge cases are very important. Now the complaint is that, as I told already, if you are putting something in a double quotes, it is not a string as we are having it in other languages. So we call this as a slice. So the result is, we are expecting an ampersand str, but what we are returning is a string. So there is difference between both this. So what we can do now is, we will make this into an ampersand str, and then we'll get one more error message. So the expected enum is std result found ampersand str. So let us first make this a string so that you can enjoy what this error is all about. So as we are encapsulating this result within an OK, we have to wrap this within something called some ERR, because the result is of two types. What is if everything is OK, what is if something is wrong. So we can put this into ERR and then the value. So now what it's saying is this double quotes is not a string, but it is different beast that is called as an ampersand str, called as a slice. So either I can do a dot to string to this to make this to work. See? So cargo test. Now what we are having is we have lot of errors now. Exchange for one is returning a result, but what you are checking against is a ampersand str. Okay, so what we are going to know is this value is contained inside a result. It is not directly available as p. So we have to unwrap this to get the actual value. So when we unwrap this, the value that is contained within that OK will be emitted or will be available for this method. So the unwrap will give you what is inside the OK. Okay. So now everything is passing. So there are some best practices that what we have to follow now. So we will go back to apply this best practices now. Okay. And the first thing is that we don't want to return a string for this. Rather, I want to return a slice or some stack, because whenever there is a value that is less than 0, we are going to return the same kind of a thing. We don't want to create a slice each and every time. So one thing that what we can do is we can put something called as a static. So this is called as a lifeline operation. So lifetime, we will have this lifetime things later. So now the way that we can return a slice, the lifetime is put a static in front of this. If there is no static and if you are putting like this, the Rust compiler is going to tell you that missing lifetime specifier. So we'll provide a lifetime. So what is the lifetime specifier? Or help consider using the static lifetime specifier. So you can just link to the Rust compiler that will give you the required help to do what you have to do. So now this is another way of doing. So we have not created a string each and every time. And again, what we can do is that we can keep this somewhere. And we will need something for this, a constant error message. So we will put a capital for this error message or message ampersand str. So this way we can make this message into a constant of type ampersand str. Now we can provide this error message here. Now we go forward. So now it is a good piece that complies to the But one of the best practices, let us keep this message as a static or a constant. The second is, there is a way that we can reduce the number of lines here by using a macro called as a vec, which is equivalent to let new slots equals vec, a macro similar to the println. So within which what we can do is we can provide them one after the other. So literally it is equal to if you are creating a vector and then you are pushing each of these slots in an order, and we don't want these lines. Now what all we want is we have written these slots, and instead of a semicolon we are going to put just a comma. Okay. And we again don't want this let mute slots because we are not mutating anything, so we can remove this mute now. And again, I don't want to keep this inside another variable. I can simply remove this thing and then I can remove this thing. Now the get slots method is more elegant than before. Fine. So now we can move this constant upward. Okay. So we have slot and we have get slots and then we have an exchange for. And now we'll come up with one more surprise. So people are very happy about our coin tender machine. So if we get one more order from a different country, that we are not using P for penny and the N for nickel, our denominations are different, and how to modify this or refactor this to accept different slots with different kind of denomination. That is going to be another interesting exercise. So we will do that as another session. So now to recap, we learned a lot of things. So because our primary idea is to show you how a test can help you in improving the design. And I deliberately played I put Rust in in a low profile or dim light, just to tell you that how you can improve your algorithm just by following the test driven approach. That is a primary objective. So if we recap what we did so far is that we started creating a system or a kind of a framework to have the features, that is a specification of this machine here, and then the machine is something that is just responding to what we are asking for, and we tied both of them in a module, and we have made this feature not as a public one, it is just a private, it need not be available outside, and we have made this machine as a public module, and so that we can use this from main. So if we have to check whether we can use this from main is, so let us just invoke this, let us use this machine colon machine colon exchange for println exchange sorry, exchange far. Let us give an input 0, my goodness, because 0 dot unwrap, you are getting an error, so it's panicked here. So let us pass the same thing here. So it's working as we expected. Okay, I cannot save this. So result of 18 is D and PPP. Thank you.